Today we talk about problems involved in rules of inference. Problems in rules of inference. Okay. The very first problem is, if it rains heavily, then traveling will be difficult. If students arrive on time, then traveling was not difficult. They arrive on time, then it did not rain heavily. Check the validity of the conclusion. So this is a statement of the problem. I repeat once again, if it rains heavily, then traveling will be difficult. If students arrive on time, then traveling was not difficult. They arrive on time, then it did not rain heavily. Check the validity of the conclusion. Okay. So for what we are going to do here is, first you are going to frame the prepositional variables. So I can start first P. If it rains heavily, then traveling will be difficult. So I can write the statement, it rains heavily. It rains heavily. Second prepositional variable is traveling is difficult. Traveling is difficult. Traveling is difficult. And third statement is students arrive on time. Students arrive on time. Any other statement you have? They arrive on time, then it did not rain heavily. Okay, these are the statements. Any statements are new in the problem? Nothing. Okay. So after assigning the prepositional variables, you are going to construct the statement symbolic manner. So how we are going to construct the statement in symbolic manner? So first statement H1, if it rains heavily, then traveling will be difficult. If then, here the logical operator is if then. So if then means conditional statement. If it rains heavily means P. So P conditional Q. The first statement, the symbolic manner is P conditional Q. What about the second statement H2? If students arrive on time, then traveling was not difficult. So once again we have conditional statement. If students arrive on time, then traveling was not difficult. Students arrive on time. Here the prepositional variable is are. If students arrive on time, then traveling was not difficult. Traveling is difficult, we can represent it by the prepositional variable by Q. But here the statement is traveling was not difficult. That means are conditional negation Q. What about the third statement? They arrive on time. So the third statement is they arrive on time. That means are. Okay. So what about your conclusion? Then it did not rain heavily. It rains heavily is P. So your conclusion is negation P. So using these premises, we are going to construct a valid argument, whether the argument is valid or not. Okay. So using these premises, we are going to construct conclude the conclusion. We are going to derive the conclusion. Okay. So for that you should follow some standard procedure. One. So first one, you can form a table, statement. Here you can write reason. Remember, so these are all premises. Using these premises, we are going to derive the conclusion. We are going to arrive the conclusion. Okay. So remember, all the premises are introduced in the problem. Okay. First one, you can introduce any of the premises in anything, anywhere else. It is not necessary to introduce the first premises first, second premises second, third, fourth, etc. Not like that. You can introduce any of the premises. That is your choice. Okay, so first I am going to introduce a premise, P conditional Q. So here you can write rule P. So what is rule P? Did you remember in the last video I will explain. Rule P is nothing but what? A premises may be introduced at any step in the derivations. So here first I can introduce the first premises. So I can write rule P. Okay, so second one. So I am going to apply some rule, negation Q conditional negation P. Here I can use rule T. What do you mean by rule T? A formula may be introduced in the derivations. Here the formula is equivalence, contrapositive formula. Using one, I am going to use the contrapositive. P conditional Q is logically equivalent to negation Q conditional negation P. This one I can call it as contrapositive. That's why I can write rule T. Rule T na a formula may be introduced in the derivations. If S is tautological, not only that, if tautologically implied by one or more of the preceding formulas in the derivations, we can call it as rule T. Okay. Third one, R conditional negation Q. So once again I am going to introduce the premise second one. So I can write rule P. Okay. And fourth one. So what is derivations to negation Q conditional negation P or conditional negation P. So here I can use hypothetical syllogism. So what do you mean by hypothetical syllogism? R conditional negation Q conditional negation P. So directly I can write R conditional negation P. So here also I can use rule T. Rule T means formula can be derived in the derivations, introduced in the derivations. Here the formula is hypothetical syllogism. Hypothetical syllogism by using equation 2 and 3. Okay, fifth one. So here I am going to introduce a premise R. So here you can write rule P. So I can introduce all the premises in the derivations. So finally you are going to get the conclusions. So here I can use modus ponens. Modus ponens is P conditional Q, P, therefore Q, isn't it? So R conditional negation P, R, therefore negation P. So this also rule T. So using equation 4 and 5, here the rules of inference is modus ponens. So I derived negation P. So likewise you can solve the problem. So okay, now I am going to explain one more problem using rules of inference. Show that T conjunction S can be derived from the premises, P conditional Q, Q conditional negation R, P disjunction T conjunction S. Okay, this is a statement of the problem. In the previous problem, theoretically some statements are given, but here symbolic representation of the statement is given. So no need to convert, because symbolically it is given in the problem. Using that I am going to derive the conclusions. T conjunction S. So these are all premises. So I can write the premises one by one. H1 P conditional Q, H2 Q conditional negation R, H3 R, H4 P disjunction T conjunction S. So these are all premises. Using these premises I am going to derive the conclusion as T conjunction S. Okay. Now I am going to prove the results. So once again I can write statement and reason. Statement, you can write the reason, that is very, very important. That's why I am telling that you have to remember the rules of inference. Okay, first one, I can introduce the first premises P conditional Q. So he can write a rule P. So already I told you rule P, that means a premises may be introduced at any step in the derivations. It is not necessary always you have to introduce the premises first one, and second one, third one, not like that. You can introduce any of the premises in the derivations anywhere else. Okay. Second one, using this I am going to introduce another premises Q conditional negation R. So once again I am going to write rule P. Second premises also I am going to introduce now itself. And third one, I am going to apply rules of inference. See, P conditional Q, Q conditional negation R means P conditional negation R. So rule T, because formulas I can introduce in the derivations. So rule T. Using equation 1 and 2, I am going to use hypothetical syllogism. Hypothetical syllogism. I can write P conditional negation R. Fourth one, R conditional negation P. So here also I am going to use a formula. That's why I can write rule T. The formula is introduced here. Using equation 3, I can use contrapositive formula. What is contrapositive? P conditional Q na? Negation Q conditional negation P. So here P conditional negation R, negation of negation R is R, conditional negation P. So I am going to apply the contrapositive for third one. Contrapositive for the third one. Okay, fifth one. So I can introduce the premise R. So here I can write rule P. Now tell me. And sixth statement is C, R conditional negation P, R. Therefore, negation P. Here I am going to apply some formula, that is rule T, using modus ponens. Applying equation 4 and 5, I can use modus ponens. And finally, only one more, my premises only left over. So now that I can introduce here T conjunction S, P, rule P. So finally I can write T conjunction S. See, negation P, P union T conjunction S, I can apply disjunctive syllogism using equation 6 and 7. Disjunctive syllogism. So memorize all the rules of inference. Nearly 10 rules of inference are there. You have to memorize all the things, otherwise you can't write this. Memorize the things, after that only you can write easiest way.